Welcome to a lecture series on linear algebra. In the few previous videos, we have seen several examples of subspaces. In this video also, we are going to continue with the same. Let us get into the lecture. Here, the space V of f is considered to be the real valued function in a given domain of R, which means you may take any domain you may take any subset of R from that subset. Okay, let me take S, okay, which is a subset of R. From this to R I am defining the function. Okay, I am collecting all possible functions of this sort, and that is my V of f. Okay, here I am considering several non-empty subsets of that space, and we are asked to check for the subspaces, right? Let us start. Okay, in the first one, set of functions satisfying this differential equation. Okay, let me take two functions from W1, which means what? Okay, generally what should we do? We have to check. Okay, let me write the general condition first. We have to check if we take two functions from the subset implies alpha times of f. This alpha and beta are to be taken from R. This is in W or not. This is what we need to check. Okay, in the first, let me take these two from W1, which means let me write that as d square plus 7d plus 1 times of f is 0. In a shorter notation I have written, okay, and d2 plus 7d plus 1 times of g is 0. Here d denotes d upon dx and d2 denotes d square upon dx square, right? This is what I have. Now I need to check whether d2 plus 7d plus 1 alpha f plus beta g also satisfies this condition or not. It is a function of two terms. I may split this to be, okay, for shorter notation let me take this to be simply L. Okay, this is L times of alpha f plus L times of beta g, right? Alpha and beta are scalars. When you differentiate, that is not affected, so you can take this outside. L times of f plus this beta times of L times of g. What is your L of f? This is your L of f, and that is 0, so it is 0. It is your L of g, this is 0, that is why it is 0. So alpha times of 0 plus beta times of 0, you are getting it to be 0. Therefore your W1 is a subspace, right? So in the second, what they have given that it is a continuous function. Just make use of the properties of continuous functions for the second one, and for the third one make use of the differentiable function properties. That is, f is continuous implies alpha times of f is continuous for any scalar alpha. Okay, f and g are continuous implies f plus g is continuous. You may replace this by differentiability as well. Okay, so if you make use of these two properties, you can prove this and this are W2 and W3 are subspaces, right? Now let us get into the fourth one, that is all those functions satisfying this condition, right? So what I am doing is that we are taking two functions from W4. This means my f of x is satisfying this condition and g of x is also satisfying this condition. Now I have to check what? I have to check alpha f plus beta g. Let me evaluate this at minus x. So this is alpha times of f of minus x plus beta times of g of minus x. Let me multiply k before. So this is going to be the case. So this is k times of alpha into f of minus x plus k times of beta into g of minus x, and these two are scalars taken from this reals. Therefore it is alpha times of k f of minus x plus beta times of k g of minus x, and this is going to be alpha times of f of x plus beta times of g of x. So we proved the requirement. Therefore W4 is also a subspace. Right? Now let us get into the fifth one. If you just closely look at the subsets W5 and W6, you can notice something. So all those functions satisfy this property is called as even functions. So W5 is the collection of even functions and W6 is the collection of what? Odd functions. So a function is said to be even or odd based on these two conditions only. Right? Let me take two functions from it. So this means my f of x is f of minus x and g of x is g of minus x. Here what is going to be the case? If I take these two are from W6, this means f of x is minus f of minus x and g of x is minus g of minus x. Let me consider what? Alpha f plus beta g. Let me evaluate this at minus x. Here also I am going to do the same. Alpha f plus beta g I am going to evaluate at minus x. Okay. So this is alpha times of f of minus x plus beta times of g of minus x. And what is f of minus x? It is f of x. And this is g of x. So this may be written as alpha f plus beta g whole evaluated at x. So I am getting the requirement. So this is a subspace. Right? Here let me come. It is alpha times of f of minus x plus beta times of what? G of minus x. Okay, from this, what is your f of minus x? It is minus f of x. So you just bring this minus to this side. So minus alpha f of x. Here also you will have minus beta g of x. So take minus as a common one. Right? So minus alpha f of x plus beta g of x. So this is going to give you that minus, you just bring this minus this side. So alpha f plus beta g of minus x is alpha f plus beta g of x. So this also satisfies the required condition, therefore it is also a subspace. Right? Now for differentiable functions we have properties. For non-differentiable functions we do not have any properties, which means we will have to check something. So for non-general cases like this, differentiable functions are general cases. Like what I mean here is differentiable functions have some properties, whereas non-differentiable functions do not have any property apart from only one property, that it is not differentiable. So I will have to take random functions and check for whether it is satisfying the requirement or not. Okay, let me consider my f of x to be absolute of x for all x in the domain, specified domain, right? And let me take here, it may be any domain, right? Let me take this to be minus a comma a. 0 has to be present in it so that it is not differentiable at 0, right? Similarly, let me take g of x to be minus absolute of x for all x in S. Okay, it is also not differentiable at 0, 0, which means if I plot this in a graph, what will I get is that I will get like this, right? When I try to plot the second function, my g of x, I will have like this. These two functions are not differentiable at 0. Okay. At other points they are differentiable. So in other points the sum is going to be differentiable. Now the only thing Where I have to check is that I have to check at the point 0. Okay, let me simply add f of x plus g of x, which means I have chosen my alpha and beta to be 1. Okay, what am I going to get? I am going to get 0, which means this is a constant function. We know that constant functions are differentiable. Therefore, my alpha f plus beta g evaluated at the point 0 is differentiable, whereas f at 0 is not differentiable, g at 0 is not differentiable. So I am getting the linear combination of these two things at 0 is going to be differentiable function. Therefore, it is not a subspace. Hope this lecture have given you an idea, a very more clear idea about the subspaces. In the upcoming lecture, we will see few more properties of subspaces. Thank you for watching this lecture. If you have any queries, you can post it in the comment section. That will be clarified within 24 hours of time. Thank you.